Welcome to Chain of Thought. On this week's episode, we're going to be talking a bit about Scale's latest research in benchmarks, specifically for MCP evaluations and MCP agents. My name is Brad Kenstler. I'm the head of agent capabilities and environments research here at Scale.
I'm Chaitanya. So I've been working on the MCP evals for a while, so excited to share what we have.
I'm Sami. I work as a product manager owning all things tool use.
And I'm Chetan. I lead the product team for agents and environments. So we have lots of exciting updates to share on this new benchmark, which is one of the first to test out MCP capabilities. And we'd love to dive into the research behind this, but do you mind giving us an overview of what MCP actually is?
Yeah, so MCP stands for short for Model Context Protocol. It's basically it's in the name. Just, it's a way for standardizing how you provide context to models. And other communication protocols exist, but this is the one that is the most widely adopted in terms of standardizing it. So a brief context on that. LLMs are like the brains of the system. In order to make agents that are reliable, that are actually able to do things that we do on a day-to-day basis, they need access to information that they can retrieve externally and also be able to make changes in the state outside of their own internal memory.
Yeah.
And so to do that, we need ways to connect LLMs with a lot of different tools. Now, MCP is the most widely adopted standardization of that. Previously, we had many that, maybe they weren't as widely adopted in terms of standardization.
Right.
Yeah.
And this is a standard that has been really embraced by developers. So it's been, it has gone viral the way, and AI is all a developer play. So whatever developers embrace is what's going to be there for a while. So MCP is something that developers really like.
Right. And I'm curious, what came before MCP? If I was building an agent application in 2022, right? How did I do that? And how does MCP sort of change the game for the space today?
Typically, back in 2022, the conversation was most around RAG systems.
Mm-hmm.
And so you'd have, which is complementary to MCP, but it's basically having external information that you get and then plug into your LLM so it's more grounded. But the communication between different servers, different external services and models, that wasn't standardized. OpenAI came up with their function calling API. That's one framework they provide. Other companies like LangChain, they have their own systems for how to standardize communication between models and external services. But MCP came out last year, and it provided a way for both ends of it, the model builders to adopt it, and also the third-party services to come up with abstractions that anybody can then use. So
yeah, end of 2023 to be exact. But yeah, it's been amazing since they came out, led by Anthropic, and it's been great after that. Yep.
Yeah, I think one of the exciting things about MCP is how the standardization around this protocol has made it easier for both sides of the ecosystem to build something that's compatible, right? If you're thinking about, hey, I'm a SaaS provider, right? And I want to make my service readily available to model MCP clients, right? Or agents. I now have a protocol that I can design for. I can release an MCP server. And so now anyone that's actually building an agent, right, it's dead simple for them to just use that MCP server, integrate it into their MCP client.
Yeah.
And so this sort of decoupling, so to speak, of having to build fit for purpose connectors, I think is what's really turbocharging a lot of this and making it exciting.
Absolutely. Yeah. So to add to that, there's, let's say, three parts, right? There's the developer, and then there's all the model builders and LLMs right here on the left. And then there's the developer and all the third-party services here on the right.
Right.
Each one of them can have its own line in how it's integrated. So developers had to write their own adapters. And so MCP makes it such that you don't have to, each one of those lines can be abstracted away. And it's very simple to plug any third-party service with any model builder as long as they adopt it, which recently we've seen a lot of companies adopt it.
Yeah.
So, super cool.
So what specifically about MCP makes it different from traditional APIs?
I think it's more of a standard. So you think of REST API for web development. So before that, there used to be a lot of protocols for web development. REST API just made it easier for folks to educate themselves on how to build applications, and that's the standardization that's bringing out the power of MCP. So it's more of, hey, is it the only way? It's not, but it's the standard way, so that people can now take away that mental effort to build a new one. Yeah.
Right.
Yeah. So I think, that standardization definitely increases overall adoption. And, MCP is obviously emerging as kind of the de facto solution now for how, we think models are going to interact with different services, different, systems and access data across them. I think to maybe contextualize this for the audience, can you give us a few examples of, MCP servers that are maybe popular or that we think, a lot of model developers are going to want to figure out how to integrate with and improve their capabilities on?
Yeah. So I think this really depends on the use case that somebody targets, but you can have MCP servers for your ERP system or your CRM system or your communications channels or your productivity systems, note-taking, even your social media channels, right? Depending on the use case. And so let's take an example of Notion. A lot of people use Notion as their note-taking platform. Somebody, whether it's Notion or a third-party developer, might build an MCP server, and then they'd expose abilities to another developer that would then be able to either read information from Notion or even update things in Notion. For example, reading one of your pages around one of the reflections that you had and then updating with a table. So Notion is one example. But there's a lot of interesting ways you can mix and match these. You might have your note-taking system have an MCP server that connects with your Salesforce MCP, and you're able to create a lot of tasks that kind of
and even for fun, so there's a YouTube MCP server, there's a WhatsApp MCP server, Slack MCP server.
What do you do with the YouTube MCP server?
The LLM can access the transcript, for example, and then find better YouTube videos, for example, right?
Mm-hmm.
So it's again, applications have been growing. So once the standard is there, you could put many things together and then build many things.
Actually, one thing I'm curious about is who's building out these MCP servers, right? Aside from the training and the eval work that we'll talk about, but is this being done by the third-party services themselves? Are there independent developers that are contributing to the overall ecosystem?
Right.
Yeah.
Yeah, so in fact, for example, each MCP requires something, behind that.
Yeah.
For example, like say Wikipedia. So there are, official Wikipedia MCP servers, and there are third-party folks that, give access to Wikipedia as well. So it's been a mixture. Slack has its own MCP server. WhatsApp, there are many official and unofficial servers.
Yeah, so a lot of them have their official ones, and then a lot of third-party services. Third-party people will just build their own.
So like if I wanted to make a MCP server, like say for AWS, right? Like, is it something like I would like take Bodo 3, right? Like the Python SDK for AWS, and then basically like wrap some, like use some MCP framework or something, and then like create some tools that invoke the API.
Exactly.
Okay, so it's
you
basically
can
like
launch an instance, for example, or check how your instance is doing.
Right.
So you can in fact talk to it, just like an API call, but in a format that's understandable by an LLM.
Right. And so basically any APIs or SDKs that are out there, you can wrap an MCP around it.
Yeah.
Okay, so I'm kind of curious. I think before we move on to talk about the benchmark, like. We'd love to drill down into like what an MCP agent is actually doing. And so I think, Sami, you were talking about tool use earlier on. And like, can you maybe just like, can you guys define for the audience, like what is tool use? Like what does a tool use agent do?
Yeah. So two things that are needed for an agent to be able to do like meaningful work. One is to read information from external sources, and then the second part is to be able to make updates to any external information. And so when we talk about tool use is the way that the general umbrella under which LLMs are able to do that. And that's able to do that programmatically, because we're not talking about the GUI, the graphical user interface side, that's different. But to programmatically do that, tool use is the concept. Now, concretely, let's say if you're using the OpenAI function calling API, an agent would be passed in a certain number of tool definitions based on that format. And then when a user asked a question from the agent, the model would then look at the prompt, look at its available tools that are available to it. In that reasoning, it would decide which tool to call based on the description, and then send a function invocation back to the scaffolding running the agent. And then that scaffolding then runs that function with the provided parameters, creates the output, sends it back to the LLM reasons over the output, and then continues on into its trajectory. So that's like the concrete flow. And then MCP just provides standardization in those communications.
But for agent themselves, there's, as Sami mentioned, the access to the tools, but the agent also has to figure out which tools to invoke, right? And that's the part where LLMs are good at, thinking about reasoning LLMs and so on. So they are able to use that reasoning power to figure out which tools to call and then how to use them.
Right. So in terms of like packaging tools, an MCP server is kind of like a box that like contains tools that the like developer defines.
Right.
And then when you connect an MCP server to the client, it basically exposes those tools to the client.
Yeah.
And that way, in terms of like context engineering for tool use, it solves like a practical problem where like the individual developing the MCP client doesn't have to like define all the tools in advance a priori, right? It's all packaged in the MCP server. And so now like that decoupling makes it easier to build the agent clients as well.
Exactly.
It's really interesting. So Chait, I'm curious, you were talking a bit about like, one of the things that's important is picking the right tools and things like that. So that's probably a good segue into our latest research around MCP evaluations. So I'm wondering, can you tell me a bit more about like how Scale thinks about evaluating MCP capabilities?
Right. Yeah, I think one thing that I want to firstly stress is this is a sea change in the capabilities of LLMs. And think of it as like in human civilization, people had brains, they were running around, finding animals for themselves or eating fruit. But then what changed in civilization is access to tools. Think of Bronze Age, right? So that's the kind of situation we are in right now. Where we have LLMs that are really good at reasoning internally, but now they're being given superpowers, right? By giving access to these tools. So, which means that now LLMs have to not just think about using their own memory and knowledge, but also extend themselves by using the right set of tools. And this is the capability that we are trying to figure out in our benchmark, is to understand how good are LLMs to actually extend themselves by using external tools. And at a high level, that's what we're trying to figure out. R is earlier we used to have, let's say prince and princess training themselves to use multiple tools. So we are trying to figure out, okay, are LLMs doing good at using these multiple tools? That's what we are trying to figure out. Yeah.
And the approach here is in creating how do we evaluate it, is try to replicate the difficulty and the realism of tasks that we would face in the real world. And so, as we'll talk about in the benchmark, it's not just a problem set, but also adding on a sandbox or an environment that contains real data from external MCP servers and a diverse set of them, coupled with like difficult prompts that then make it we think it's more realistic of a benchmark.
Yeah, we are not the only ones thinking about this because this is such a key foundational capability for LLMs. But where we differ is the diversity of tools that we are testing it on, that we are giving access to the LLMs and then checking if they are able to, simultaneously use a Notion MCP server, which is about productivity, versus an entertainment MCP server.
Yeah.
Is it able to understand this, capture this diversity?
Yeah. And just so it's abundantly clear to the listener, the big news here is that we're launching an MCP benchmark.
Right.
Yeah.
So we're super excited about that. And that's what we're talking about.
No, I mean, this is all very exciting. I think, when it comes to like the tasks, right, that are included in this benchmark, the sort of problems that we are, feeding into the model, like more concretely, what are all of the different capabilities that we're testing for? So I've heard a few things so far, including, the ability to pick the right tool to use, the ability to actually reason through multiple different outputs or to use multiple tools in conjunction. Can you maybe just map out like what does a good task look like and what are all the different types of capabilities that we want to be able to test models on?
Great question.
Yeah.
So thinking about, again, going back to what are we testing for? We are testing for a model's ability to answer a certain question or do a certain task by invoking multiple tools that it has access to, right? So the first thing that we test for in these prompts is it choosing the right set of tools, right? Is it choosing the right ones? Is it missing any needed ones? Is it ignoring some of them? So we test for that. The second one is, now once it picks a certain tool to use, is it good at using that tool? Is it using it correctly? So this is where we talk about, is it calling the right API function in the correct way, right? Now this is about, again, picking, calling it well, but then finally it gets back all the context which Sami was mentioning. Is it able to understand all the context and then digest it, understand it, and reason on it, and then answer the final question? So these are the three broad capabilities that we're testing for.
So it's really these end-to-end tasks,
End-to-end
right? Where
tasks,
you're evaluating how well can it reason through a set of tools, and then complete that pipeline up until it provides the right answer.
Yeah, great part.
Yeah.
So it's the end-to-end. So that's why creating tasks for this is also, we need to do that carefully. The task should be self-contained and it should be very clear what the task is asking for.
Yeah.
Right. So that's the key idea, and then it should enable or it should require multiple tools to be called, and then digest a lot of other information and aggregate a lot of information to answer the question.
Yeah.
So that's the key part that we do here.
Yeah.
So I'm curious, can you drill down into what does it mean for a model to use a tool effectively? So you spoke about these three things, right?
Yeah.
Like selecting which tool to use, using the tool, and then digesting the output.
Right.
But concretely, what does it mean to use the tool effectively?
Right. Yeah. This is where I think we haven't talked about the environment. So a key difference in this benchmark compared to, let's say, other types of capabilities that you test. In other capabilities, you have a question, the model does all the thinking by itself internally, and then answers the question, right? So this is the first time we have, we are evaluating model capabilities, which requires an external environment. This external environment is essentially the box of tools. So, what it takes to finish a task is it needs to connect well to that environment. The environment should be robust, should not fail, because we are evaluating LLMs. We should not have a buggy environment, because then, we are evaluating the environment and not the MCP, not the LLM itself. So that's the key part that we made sure that the environment is robust, reproducible, and then now LLM is able to use that environment to call certain tools. By calling, we mean, it's literally making an API call or MCP API call, right? And then getting the answer and then digesting it.
Okay.
So specifically there, when we have in the calling portion, so once it's got a spec of all the tools that are available to it, and the spec includes all the tools as a JSON list, and then it includes a description of what the tool is, so that an LLM is able to pick the right one. Because when there's many, we need to have that clear. Once it picks the right tool, then it's about creating that function invocation with the right parameters, and then that's what it means to call it. And a lot of times they either pick the wrong tool, or they pick an inefficient one when a task that could have been done with one tool, with one call, sometimes they pick another one that has to be done 5 times. Let's say Google distance matching, for example. And sometimes they might not pass in the parameters properly. Right. So that's what we mean by calling the right tool properly.
Yeah.
So if I'm kind of going with this analogy you had earlier about the LLM as a Bronze Age caveman, right? Yeah. So that, you're this caveman. You've been given this task, go build a bridge or a dam or something. Right. I don't know what Bronze Age cave folk were doing. And your environment's like this box of tools, right? Like you might have some kind of hammer thing or some knife. Yeah. And so
should be worse.
Yeah, exactly. And so the model has to figure out which tools do I want to use in this box. So that's part of it. But then also once they're using the tools, how good can they use? How effective are they with a hammer, right? And then if they use the hammer and they see that the hammer is not working or it is working, they need to figure out what do I need next, right? And so there's kind of long horizon thinking of using these different tools to accomplish some tasks.
Yeah, it's a multi-step process, right? As you correctly mentioned, maybe you need to use the hammer to break the shell and the knife to cut it down properly. Right. So this is the type of multi-step thinking that we are evaluating our LLMs for.
I think more importantly too, you might realize, this hammer is not breaking the shell.
Exactly.
Now what do I do? Yeah. Right. So you need to recover from these failure modes.
Exactly.
Yeah, I think just piggybacking. Yeah, that's a great analogy. And
it was Chait, so I sold it.
Yeah. Yeah, I think just piggybacking off of that, Sami, one of the things you mentioned earlier was that, there are kind of like two functions that exist within this realm of like, tool use in MCP, right? One is information retrieval, where, you are essentially like pinging these servers to get information back that you can use to reason through. And the other is actually performing actions or like mutations within that service. How do we think about both of these capabilities? And, are we capturing both of these in our benchmark today? Do we think one of these is maybe more important than the other when it comes to how people are actually using this in a production environment?
Great question. I think here it talks about the environment, right? So
Right.
in order to get access to information that's out there. In fact, in our environment, we have a lot of real world data and artifacts that we have collected,
Right.
and which we are populating this environment with, so that let's say real world Slack conversations. They're literally there's an environment where we have Slack conversations, and then people can ask questions on it, right? So we have that, but the other aspect is writing to it. So we currently don't have that in the benchmark, mainly because we are open sourcing it. We don't want people to corrupt each other's environment.
It's hard to build these
It's a hard
environments
thing.
too.
Yeah.
Exactly.
But that is like that's an important capability that we will explore. This is just the first of several benchmarks.
Yeah,
absolutely.
So can you tell us a bit about like this environment specifically? Like, I mean, what's in it?
Right.
Yeah. So 3 parts to the whole benchmark. It's the data, which is the evaluation task, like 2,000 tasks that you can run on. Then
2,000.
2,000
lot.
tasks.
Yeah. Cool. Oh, that's actually one of the places where we differ from existing benchmarks. So we went diverse and large number and difficulty as well. So difficult tasks as well.
Cool.
Yeah, we can get into the performance numbers in a bit, but 2,000 tasks. Then we've got the environment, and then we've got data that we have to seed some of these environments with, which Chet just talked about. I'll go into a bit of detail. So the environment basically is a Docker container of MCP servers. There are 40 plus MCP servers ranging from productivity to project management to social media like YouTube. And then each one of those servers has a number of tools attached to them. So in aggregate, it's about 300 plus tools. For those 2,000 tasks, each one of them target different servers and different tools in different ways. And so we expose those tools to each model per task. Now, some of these servers have to be stateful in nature. For example, Notion. For example, the local memory knowledge graph that we have, right? They don't have any information within them by default. So that's where we've done the work to have real-world data, acquire real-world data, and then populate them with this data so it resembles let's say real CSV files from other businesses.
Sorry, I just want to double click on that. So what you're saying is that the different like systems in this environment that like need real data, like we've acquired data somewhere, real world data, and like put it in these environments. It's not synthetic in any way.
Some of the data for some of the servers is synthetic, but a lot of it is actually real world data that we've acquired from real businesses.
Right.
And an example of this might be like shipping logs, etc., that a company might have. And so some servers like Slack, for example, we have done the work to generate a lot of conversations and seed the servers with. Other ones, for example, Notion, Airtable, we have a lot of real world data that we've populated them with, and then the tasks use them, and the models are able to interact with them. So it really reflects the realism of the data. It's not synthetically generated.
And does each agent is it given the entire tool set and MCP servers, or how does that work?
Yeah, so for every task, we don't want to give all the 300 plus tools for every task. So in every task, we have target servers that we call. So basically, let's say a subset of them, let's say 30 tools, right? So among those 30 tools, we are evaluating is the model picking the right tools.
Sure.
So that's why we don't want to give everything and then confuse it. We give subsets because we are trying to evaluate models on different capabilities.
It also, a lot of models don't even support the full 300 plus. For example, GPT-4o supports 128, as far as I know, in a single conversation. And so that then combined with the subset that we do enable, that also includes some servers that are very relevant to the task at hand, but then others that are distractors. Right. And the point of the distractors is to be able to simulate real-world scenarios where they might have to choose the right one amongst others that might confuse it a little bit. That's one of the things that makes this benchmark that we believe more difficult.
Yeah, and this is something we talked about in a previous episode on how to make new evals that capture real world distributions, actually seed them with data that exists in actual business processes that look very realistic and are not synthetically generated. So, really proud of all the work that the team has done here. I think the other thing to celebrate is that we are open sourcing this environment, and that's not something that you hear very often from data companies. Can you talk a little bit more about our decision to do that and how we think this is going to benefit the research community?
Yeah, we really think so. We are at the beginning of this evaluation of LLMs on these capabilities.
Yeah.
So we want developers to, in some sense, customize these these tasks and the way they're evaluating as well. So that's why we want to make sure the environment is something that any, let's say, any student or a PhD student doing some research can quickly download and then set it up on their laptop and then start evaluating their own small LLM, right? So that's the key, and that's why we took some effort to figure out what are some good MCP servers that are robust to many people using them at the same time, and then that's how we chose 40 and diverse enough that we have some people who are interested in building social media tools versus people who are doing deep research can also use. So the open sourcing serves that purpose.
Yeah, and to be clear, the environment is fully open source as well. So you get the environment, which contains the MCP servers, and you also get the ability to create trajectories for all 2,000 tasks for any model of your choice that you want to evaluate, let's say. And then you also get the evaluation scripts that we use to compare those trajectories against what we think, evaluate those trajectories, right, and get some failure mode analysis on that. So anybody could, at a lab or a researcher, they could spin it up and they could get insights onto the model that they want to evaluate. And they're also able to freely mix and match. They're able to choose what they want to modify. They can change the evaluation script if they want a bit of a different failure mode analysis. They can extend the environment. They can add their own MCP servers. They can create their own problems if they want. So I see it as a three-piece system, and people are able to change and extend as they want.
That's really exciting. And, I know we want to talk a little bit about how models are actually performing on this benchmark, what makes this, one of the hardest ones out there. But just to, give a little bit of context before that, can you talk about some of the other, benchmarks that a researcher might use in conjunction with, our new MCP evaluation to gauge, tool use capabilities?
Yeah, so there are some other, benchmarks that are measuring tool calling abilities.
Yeah.
There's one from Berkeley, it's called Berkeley Function Calling Leaderboard. And, there's something called Taubench. So there are a bunch of those. But where we differ from a lot of these is the scale, for the lack of a better word. The diversity of the types of tasks that we have and the difficulty. So that's where we're eager to get to that part. But diversity, the difficulty, and the number of tasks themselves. So we are open sourcing about 2,000 tasks.
I think, and correct me if I'm wrong, but there have been some recent MCP benchmarks come out, and I think one of the trends that I've noticed, and I've seen this for a few different agent benchmarks. Like there was a recent deep research benchmark that did this. There's a lot of synthetic task generation.
Yes.
And I think one thing that's interesting, and we'll talk about this when we get to the results, is that you can see a pretty clear separation between task complexity, when you're generating tasks on the fly, versus having actual humans thoughtfully craft really difficult problems that stretch a model's capabilities. And so I think it's interesting because it's, on the one hand, benchmarks that rely on synthetically generated tasks are more accessible in a way, but at the same time, you're I think we're seeing the ceiling of how complex the tasks that a model can generate really are. I think some of the recent ones that came out, we're seeing pass rates at launch in the mid to high 70s.
Yeah.
And so I think that's something that we see quite different in our benchmark. But before we get to the benchmark results, maybe just walk through what is an example task for the viewer, so they have a very clear understanding of what does a task in this benchmark look like?
Yeah. So it's just three simple parts. Each of the 2,000 tasks has a prompt that is written by a human, not synthetically generated. The prompt, in order to answer it, you need a set of tools. So those enabled tools, we have a list of enabled tools that we provide to the prompt, which includes the necessary ones and then the distractor ones. And then we include a ideal trajectory that is the ideal response to that prompt. The model would take the prompt and the enabled tools, and then it would create a trajectory, and then we would, using our evaluation script, evaluate it against what we think the ideal trajectory is.
Right.
That's the composition of a task.
So can you maybe
but as
give
a
an example?
contributor, right? The example, not to take some example from the benchmark, but one of the questions that we saw was, hey, I'm visiting Japan, and there was some time when I went to Tokyo. There was a hotel close to a sushi restaurant, and there was also a dumpling restaurant right next to it. Can you find me new hotels nearby? And also tell me, how much it would cost for me to, hail a ride from the airport to that hotel. So if you see this question, it has there's some memory aspects. So where the model has to figure out where this particular hotel is and find options for other hotels around the area. So it might have to use tools like maps, for example. And it also has to do some calculations. So figure out the distance, figure out the cost of ride in Japan, cost of taxi, for example, and then calculate that. So you can see how this very natural type of question that you would ask a travel agent, for example, will be answered by LLM by accessing multiple tools, right?
So this is interesting. So you're saying that we have like a memory tool. Okay, so basically, a lot of the tasks like provide the agent with a tool that basically gives some memory for the.
Yeah.
That's it. I mean, I think that's pretty comparable to how a lot of actual like LLM and agent applications work, especially the consumer-facing ones, right?
Yeah,
like ChatGPT.
Like we have Notion or Slack, where you could say, hey, in a channel, my friend was mentioning about a certain game, right? Video game.
Yeah.
Now, how do I buy similar video games? So that could be a question.
Right.
But even there's those external data sources, and then there's something, local memory stores that we have.
Right.
So like this memory MCP server represents knowledge in a graph.
Right.
And so, like you said, a lot of client-facing applications like ChatGPT, they have their own memory systems that persist across chats. And so this is kind of emulates that, where you have memory stored about you.
Right.
And then the agent is able to retrieve information from there, populate it with a Google search query, and then populate it into the calculator to measure distances, etc.
And this is the key part that we wanted to make sure that these prompts are realistic.
Right.
Because that's the key criticism that many benchmarks get. That, hey, okay, so you do 80% on this benchmark, but what does that mean for our real use case?
Right.
That's why we made sure that the prompts are generated by humans and trying to ask regular, usual questions.
Right.
Not, not something to stump the model, for example.
Right. One thing that you guys mentioned too, which I think is super interesting, is like this notion of distractor tools.
Right.
So if I'm recalling correctly, like an example of this is something like, I think one of the prompts you just mentioned, which is like, somebody mentioned in one of my messages that there was some movie they wanted to see or something like that, right?
Yep.
Where basically the prompt is saying, it's suggesting that the agent needs to search through some messages.
Right.
And then the tools that are enabled are things like Slack, but also maybe something like email, or like maybe some third like message related thing. And so the agent basically has to figure out, okay, this individual is talking about some message history. I have these message related tools. I need to figure out which one's the correct one and which one's not. Or I can just use all of them and just kind of figure out like where's the information actually stored.
Like if it says channel in the prompt, maybe the model would think Slack.
Yeah.
If it doesn't and there's nothing that it can infer from, then you would think maybe it should just start with one and then see how it goes.
Right.
That's what a human would do as well.
And I think this is very interesting because like real world agents are equipped with, dozens, if not maybe even hundreds of tools, right? And as these agents take on larger and larger workflows in order to get those done accurately, right? You just have to equip them with a lot of these capabilities. And so then a fundamental problem becomes like, how well can they understand the purpose that each tool serves? The information that they can retrieve from different sources and discern what the right ones are.
Yes.
And so I think, this idea of, including distractor tools is it's a very cool approach.
Yeah, this way we can, measure, is it selecting the right tool, right?
Right.
And not giving up, just by looking at one source and then, if it doesn't find the answer there, it shouldn't be giving it up, right? So that's the aspect that we test as well.
We talk a lot about how having rewards and having verifiers that are a bit more nuanced and not necessarily fully deterministic or binary 0 or 1 are good for this sort of evaluation. Whether it's looking at a bunch of claims, right, that have to be true for a final response, or maybe even evaluating like the process. Right? Did the agent call the right tools? Did it figure out which ones were the distractor tools? Was it able to like reason through the problem properly?
Yeah, there are two. You're right. So we are capturing two different types of analysis. One is it getting the final answer correct? So it's called the final answer correctness, right? The other one is the process itself. So sometimes models get the process right. It's calling the right tools in the right way, but maybe at the last step of aggregation, it's failing. So we also capture, okay, is it at least doing these partial steps well? So we capture those aspects as
exactly. So what did we actually learn about like what are models good at today out of all these capabilities? Where do we see the most room for improvement as well?
In a way, because our tasks are difficult, so I'll talk about where they're failing. Right?
Sure. Yeah.
So I think most of them. Also, one thing that we realize is different models. There's not much correlation between different models how they fail. So different models are failing at different things, for example, but most common things that come out are picking the right tools. So models are picking the wrong tools, and sometimes trying to answer it based on their memory, not even trying to call tools. So this is the picking the wrong tools or missing tools, what we call the failure mode. The other failure mode is not able to call in the right format. So it's not picking the right parameters. So in the Japan hotel example, maybe it will say find hotels near an address, and then it doesn't give the right exact address. It just gives a hotel name, for example, and the maps doesn't necessarily work with that. So we need to be giving the coordinates of it and so on and so forth, right? So picking the right tool, but using it wrongly, right? So that's another failure mode. And there are some failure modes on planning. If it's a long horizon task, some models, plan wrongly. So they just choose the order in which they should be calling the tools, wrongly, and then that makes them fail at the task. Yeah. So these are the common failure modes.
The primary, to summarize then, the primary ways that we see them fail the most is in tool selection and then tool construction, more so than tool output interpretation,
which is like the reasoning,
which is more of the reasoning.
Yeah.
I mean that seems to track though, right? Like I think it would be pretty surprising if models received a tool output and couldn't parse it that well. I mean, unless it was like a really oddly formatted output, I suppose. But
so there are some models that are failing at that as well. So they ignore because of the context limitations and so on.
Okay.
They can ignore. They get a lot of output in JSON format and whatever format the system is giving them, and it can ignore some of them, not put it all together.
I see. Okay.
Depends on, I guess, how long the output is. But typically that doesn't feel like. Context management feels like a problem that's been worked on more so.
Right.
Compared to tool calling.
Yeah. But it can stress a model's ability to like pick a needle out of a haystack, so to speak.
Yeah,
like a really long output dump, and you need to like find the one thing in that.
Right.
Yeah.
And then you need to invoke it word for word, letter by letter properly, because it's a literal function invocation that the model needs to provide. So it makes sense why it fails there.
Okay. Cool. Well, anything else, like just key analysis, like things you want to highlight from the research?
Yeah. So, one of the key surprises for us was the SOTA models are doing this badly, especially because when we looked at other benchmarks, they were getting 70%, right? Or plus. So that's been a key learning. The other learning is while we were developing these, we assumed that the difficulty of a task would be common across different models. But something that we saw was the correlation was quite low. So which means that models each of them are getting good at different kinds of things. So that's been another learning, which means that for LLM developers or model developers to improve their models, they have to really go deeper into where they're failing and then improve those aspects. They cannot just focus on final answer correctness and then just train based on that. Yeah.
Cool. In terms of like model progress for MCP and tool use capabilities, like tool use has been around for a while. and we're starting to see more investment on the post-training side in RL for tool use in general.
Right.
We're also seeing more investment in like tool use data in pre and mid training. And so I think base models are getting a firmer understanding of like just agentic behavior and like stateful actions in general. And so I think that will ultimately cascade downstream into gains during post-training. I also think that environments for training are going to get better, and I know that because we're going to play a big part in that. So I think that's going to be a key driver. But what I think is going to be true is that the environments that we evaluate are going to continue to get more complex.
Yes.
So like we're really excited about this benchmark. But this is just like a starting point for us, right? Like we know that we want to continue to expand the horizon of complexities within our benchmarks. And so, this captures a lot, but it's only step one. And so I'm pretty bullish that like models are going to improve here. But there's going to be another one right around the corner that they need to hill climb on too. Right. So, and I think we're going to continue to be a driving force for that.
Absolutely. Yeah.
I agree. That makes a lot of sense. I'm also very excited about with MCP, the thing that's most exciting is anybody can create an abstraction over any API and then contribute to this shared registry, which can plug into any model. The more we do that, each additional MCP server is like increases the surface area for how useful of an application you can build. And I think that then means there's more adoption on the user side. So with that cascading, what's that word? I'm forgetting a word. It's okay.
Use whatever word comes to mind.
Yeah, compounding. That's the one.
That's a good word.
I think we will see some very solid improvements, and also very excited about the environment part, and very looking forward to how people use it, extend it, add more MCP servers, poke holes in it too. That's very cool as well. We would love feedback.
Yeah.
But super excited about this.
And that's the main, I would say, ask our users. This is a very, in some sense, a live benchmark in the sense that the environment is there, so they can use parts of the MCP servers there, create their own tasks, create their own ways to evaluate. So it's a very it's not a static benchmark in that sense. So ask all our colleagues in companies, other companies, universities to really download, use it, let us know what they think of it. Yeah.
Very cool. Well, maybe we can end on one final question, which is, I think, we've talked a lot about how MCP, is a relatively new development. We're seeing a lot of adoption right now. In 1 to 2 years from now, like, how do you think this plays a role in the broader agent ecosystem? Are we just going to see thousands or millions of MCP servers?
Right.
Are there any big gaps or bottlenecks that are preventing more widespread adoption right now? Like, paint a picture of where the world is going from here.
Yeah. I think I can go in and maybe you can add on. Eventually, going back to the beginning of how we started this, a model needs to be really good at ingesting information and manipulating the environment outside of it for it to do any meaningful work. And so eventually, if we extend it, and if MCP is the standard by which all communication happens between each of these parties, it plays a central role. It becomes a critical part of that infrastructure. Now, the part that I'm excited about most is how this then plays with, let's say, computer use. Because, MCP is just a standardization of tool use, which is programmatic ways of calling APIs. But then there's also other ways where we can manipulate information using computers, browser use, etc. So I think MCP combined with other mechanisms that we have for direct computer use, very excited for that to come together. And that might be, eventually we can look into creating benchmarks there as well.
Yeah, for me, I think this, again, the first step towards using static tools. You can think of MCP servers as deterministic type of tools, right? But then what if the other entity that you are interacting with is also another agent? So this is a natural step towards agent-to-agent communication systems, right? And then is an LLM or an LLM-based agent able to leverage the right agent, not just an MCP tool, but the right agent? I think that's where things are going. And then once these agents start talking to each other, then it's explosion, right? So intelligence explosion.
Yeah, I think the saying used to be that like software is going to eat everything,
Right.
and I'm pretty bullish that agents are going to steal software's lunch,
Yeah.
and they're going to be eating everything. And so I think like and really the way they're going to do that is through MCP.
Yeah.
So I think in a year, 2 years time, basically our entire digital infrastructure is going to have integration entry points for agents, and that's going to be driven by MCP.
I agree. How would agents talk to each other? Like are you gonna wrap an agent into an MCP server?
Yeah,
then-
and there are already versions of MCP for that.
Yeah, there are
Agent to
protocols like
yeah,
agent to
protocols.
agent.
A to A by
A to A,
yeah,
yeah.
okay.
Yeah.
That one. That's very interesting.
One last thing. What's next on MCP benchmarks?
I have the same answer. I'm really excited to combine MCP. We have this benchmark. If it needs to be more difficult, we'll continue progressing there. But what I want to do is combine it with other modalities, and that's computer use. And so if we can create a benchmark which tests both tool use and then computer use, I have a problem with my VPN right now. If it could uninstall my VPN using computer use, then pull the docs via MCP server, do all of that, that would be capabilities that I would love to test.
Yeah, for me, it's the multi-turn continual learning aspect. So can we actually, check for LLMs if they are able to do multi-turn, remember the interactions they're having, and then, keep improving on that. I think this and then the agent to agent, I think these are the two aspects that I'm really excited by.
Cool. Well, thanks, guys. I think that wraps up this episode of Chain of Thought. Thanks a lot.
Thank you.
For viewers, if you have any questions, please feel free to drop them in the comments and we'll get to them next time. Thanks.